there. All right, so you had to remember this is the part where we don't know the population standard deviation. So we're going to use your sample standard deviation in place. So because, Julia, not enough is known about your population, you add a little bit of a disadvantage. So the T gives you a little bit of a better edge on this. Because we don't know what's happened in the past, so we have to use our sample standard deviation. So what they wanted you to do here was, God bless you, was just to find your critical value. These are called critical values. Remember that the book does T sub 0. I like to call it T sub C. I don't care what you call it. This is the cutoff value. Remember again, for t-squares, we don't have a p-val from our table. We can find a p-val from your calculator. But we can't find a p-val from your table, because if you look at table 5, all it is t-squares there. It's unlike table 4, where it gives you the t-squares around the edges and the area in the middle. Your t keeps changing based on your degrees of freedom. So you might be way up here, and then you come a little bit down further, and then a little bit down further till you actually make a normal curve. God bless you. So while the area under your curve stays equal to 1, the individual areas change based on your degrees of freedom. Your calculator can figure all that out. It has its own little algorithm that it follows. But we can't off your table. So remember, if it's on the left-hand side of the 0, it's negative. If it's on the right-hand side of the 0, it's positive, because all it gives you is a positive value. Good? So again, we would label this as reject H0. We will label this as fail to reject H0 when we go to label our things. So look these over. I had to do 3 through 10, so you can find them. Again, when you look up the positives, they stay positive. When you look up a left tail, you look up the positive, but you make it a negative because it's on the left-hand side of the 0. Questions? No? Okay. A two-tail test? No, two-tail test. This takes care of the two-tail test. The beauty of this, you don't have to subtract any, divide anything, you don't have to double anything. You go right to your two-tailed line. There's 2 rows on top, a one-tail, a two-tail. Go right to the two-tailed and take out your number. The left-hand side and the right-hand side are symmetric. Make the left-hand side negative, the right-hand side positive. So are we okay with this? Now, rule of thumb for your degrees of freedom. If your degrees of freedom are not in your table, you go up to the one right before that you can find. Like if I'm looking for 57, and 57 is not there, but 55 is there, I'll go use 55. Okay, so this one asked you, I did give you this. Okay, this one asked you what your decision will be. Don't forget, anything in blue is failed to reject, reject H0. Anything open is failed to reject H0. So judge where your numbers are. This is your cutoff value. This is the cutoff. If my t-score is positive, I'm in the open. I'm in the failed to reject H0. My t-score is at 0, I'm in the open. My t-score is at negative 108, somewhere right over here, I'm still in the open. If my t-score is to the left of this number, which it is, then I'm in the reject H0. Everybody do this? Yes? Yes. You still follow the HA. Whatever the HA is your tail. And because this is table 5, you don't have to divide anything in 2. You just go across table 5, it'll say one tail, it'll say two tails. That's where you get your cutoff values from.
How do you know if it is a two-tail test? Just by the letter.
But so say it says that your claim is that these two things are not equal, to 10. This is your HA. This is a two-tailed test. If it says your HA is less than 10, it is a left-tailed test. It always goes by your HA. This is a right-tailed test, regardless of what it turns out as.
The first one, it says 2.091. It would be failed to reject even though like that's a positive and the...
Yeah, no, because this is where your negative is. Where's your positive 2.091? Over here. You still only have one tail test left. The only one that you would have both sides to check on is when you have a two-tail test, such as this. These have two reject HOs. What's going on back there, guys? This is a fail to reject HO.
So for a two-tailed test, when you're finding the t-value, you double the level of significance or the plus or minus?
You don't have to do anything because your table does it for you. When you look at table 5, it's going to say one tail, level point, whatever this is, whatever this happened to be. 0.05, you look up two tailed for 2, one tailed for 1.
So for a two-tail, you can't use inverse t.
You can, but then you have to divide it by 2.
Oh, so you would take the level of significance and divide by 2 and plus or minus?
Yeah.
Okay.
If you're going to use a two-tail. Hello? Hello. Sure. Yes. Yes, and wasn't it listed there last year? Yeah. Yes, guys, could you just give me 1 minute, okay? Just give me 1 minute, I'm sorry. So he sent me a memo saying that he thought Mercy College removed the probability and statistics course. I went to the catalog, I cut that part out, I sent that to him, and I sent it to Tampon Sue, saying, this is how it's always been listed. This is the same exact write-up that we do in this course. We just don't offer the AP version of it. We offer just Mercy College of it. So I don't know how this changed. I gave it to Tampon Sue. Oh, well, so what good is that? Okay. Yeah. The same thing. Yeah. Okay. Then they won't get the credit for it. But we've always been doing it this way. Even though it's AP, we just do the Mercy College. Okay. Okay. Tampon Sue said she was going to submit it to the liaison from Mercy College to see what they said. Yes. Yes, but I told her it is the same exact write-up as last year. It is the same exact that we filed. Then that's okay. Okay. Thanks. Okay, thanks. Thanks. Bye-bye. Sorry, guys. They're trying to take away my Mercy College probability and statistics class.
Is this AP certified?
Why not just give it the AP test? I don't understand.
Because we don't really, we decided this.
Why not just make it AP class?
Because this is the problem. About 10 years ago, I started teaching the statistics. They did it 1 year with an AP. But the problem is, then they only had like, the first couple years, we only had like 5 kids in it. Because a lot of our statistics kids can't take AP if it's too difficult and they have to rely on an AP test. We would have to not do elementary statistics, we have to change it a little bit. And we would not probably get the kids that are taking Calc AP and Mercy College Stat AP. You wouldn't probably want to do 2 levels of those. So we decided, and Mercy College said, fine, we're teaching the same exact course, but no AP testing. The AP test is difficult for this, as is all your other AP tests. They're difficult. I should close this off. They're all difficult. Not for me, sorry. Sorry about that. So, are we okay with this? Yes. Okay. That was good. Okay, Marissa. Okay. This one, This one, same thing, where it's gonna fall. Now we have two tails to test with. Coast is clear. So test, see where it falls. In the open, this guy falls in the open, 1.705. Falls over here somewhere, right to the left of that. Fail to reject. Negative 1.755 falls in the blue zone. Negative 1.745 falls in the blue zone. So if you label your zones, reject H0, fail to reject H0, I think you get a better feel for what you're doing. Remember, your tail still goes by your HA. Okay. Sorry, guys. We'll get through this. All right, so basically the same setup. You're pulling out your claim. You're figuring out which one is the HO, which one is the HA. You're sketching. The tail goes by the HA. Label reject H0, fail to reject H0. Give me your test statistic. We'll put this on the calculator when we're done with the formulas. And decision is either fail to reject H0 or reject H0. Interpretation is that big chart over there. Start it and fill in your information. So we're going to start like this. He claims that the mean price of a 3-year-old sport utility in good condition is equal to $20,000. This is the claim. It's an equal, it's an HO. HA, its complement, not equal. Sketch your critical values. That comes after you look at your sample thing. You suspect it's incorrect, so you sample 22, and I put it over here. Notice we have a sample standard deviation because it's in the same sentence. It's not a population standard deviation. And is there enough evidence to reject this claim? Reject also tells me my claim is HO. So I look back to my two statements. That's a good check. And some of you turn them around, HO and HA. That should help you out. Reject has to be HO. Find your statistic. This is a T, not a Z. And it's always the sample minus the population. I gave it to you on the board, and I'll give it to you again. Sample minus population, find your T after you do your cutoff, and see where this falls. This falls in my fail to reject H0. This is my decision. I come to my chart. If I fail to reject this, do I go along with it? Yes. But I can't say, yeah, I agree. Yeah, it's a good claim. Yeah, they did a good job there. I follow my chart. My claim is my HO. I fail to reject. This is what I'm looking for. There is not enough evidence at a level of significance of 0.05, fill in the blank parts, to reject the claim that the mean cost of a price of a 3-year-old utility is $20,000. I want to see those words in there because this is the last thing you present to somebody. And that's what they're going to look for. So you don't have enough information to reject their claim. Okay? Your information supported them, didn't support it, but agreed with it, took it as good. Remember, we always test the HO. Our tail, HA. Yes.
It's kind of like off topic, but do we have a final in this class?
Yes.
Do you know when you do it?
It's June 6th. 6th and 7th. It's in class final.
If we were to take it now, how do you think we would do?
You pass it. You do fine.
That's
This
the
is
part.
like the last part of this. I did this as part 3 because we spent a lot of time on this part, and we do this like all different ways. And we do it last, so it's first in your mind as well. So I do this part 3, and so then you get some multiple choice. And part 2 are like confidence intervals, things like that. A graph.
There's gonna be like a whole interpretation, reject,
Yeah,
question,
yeah.
like.
Well,
Okay.
this is going to be your major part of part 3. It's like 20 points on your final.
How would we know if it's like it's a random sample?
Yeah, you'll know.
Do I have a formula?
No.
Yeah, you have a formula sheet.
What?
Teachers that like print out those big review packets for the
I give you a really nice review packet. And I even give you all the verbs that you need to know, all the definitions that you need to know.
So you're basically going to the test that we can.
Pretty much everything that your little heart desires, I give to you.
I got the problem.
And at the end of the review, if you just study from the review packet, you will do very well on the final. You know, I also find, and I give you all formulas, because I find like that's like wasted memory, like that's short-term memory. When you walk out of the test, you don't remember those formulas anymore, and I don't expect you to. Unless you use it over time, you don't remember it. So, and if you took this again in college, they're going to either use a program for this, a package somewhere. We can't because we can't offer a lab. That's my problem. We can't offer you a lab. So if I used a package, I'd have to have it available here. Like Andover is a package. You could even use Excel as a package to do this. But I can't offer it because I'd have to make it a lab. And that means I'd have to have a computer run all the time. You know our situation on that. Yeah. All right. So the IRS claims that the mean wait time for callers during a recent test is at most less than or equal to. It's got the equal sign, claim, HA, right tail test. Label, find your cutoff, and take out your random sample of 40. Sample information, find your T-score. Decision. That's a decision. This is the interpretation. Good? This is the easy